And is this relation a function that I'm pointing to? Yes. Why is that a function? What's the best thing you can say for the answer? It passes the vertical line test. Okay? So it's a function because it passes the vertical line test. So remember we talked about the vertical line test. If I draw this vertical line right here, remember this is where you're drawing the vertical line. I'm not going to draw those lines because I'm using this for something else. But if you draw those vertical lines, each time it intersects it. You can even see it intersects how many times? Just once each time, right? So basically that means that for this x value, there's how many y values? 1. For this x value, there's how many y values? And so on. So hence that's the definition of a function. For each x, there's only one y. So that's a function. But let's look at this in terms of finding the domain and range. So real quick, so if I want to find I'm going to put that here. If I want to find, let's do the range first. The range is easier to deal with. Remember, the range is a set of what? The what? Y coordinates. The range is a set of y coordinates. And when looking at the range, and we use that idea of that straw, remember that? We're going along which axis? The y-axis. All right, and remember, you always go from smallest to largest. So I'm going to go from the negative part of the y-axis to the positive part of the y-axis. And as I go, and always notice the properties of this graph. So notice that we have this shape. The arrows are pointing up, right? And we have a low point right here. Always notice things like that. So as I go from the negative part of the y-axis, tell me where I start touching the graph. Right here, right? Now remember, finding the range. The range is a set of y coordinates. So you got to ask yourself, what is that y coordinate here? Negative 3. So I'm going from negative 3 all the way to what? So yeah, so any of these y values are going to be on that graph, right? Okay. So the range, how do you write that, though, as an interval? Huh? No, in interval, not in inequality, an interval. Bracket. Can you even say bracket? Negative 3, comma, infinity. And infinity, negative infinity is always parentheses. All right, so that's interval notation. As an inequality, how would that look? That's my MATLAB part, inequality. You got to tell me that is an inequality. What letter are you going to use? Y, because it's a set of y coordinates, right? So y is what? Greater than or equal to negative 3. Because that says you're looking at all the y values that are greater than negative 3. Negative 3 to infinity. All right, so that's your range. Now let's talk about domain. For domain, notice that these arrows are going up, correct? And so also notice that it keeps going this way right here. So I'm going to ask you this. If this x value right here represents negative 1 million, am I going to get a point on the graph? Yes. And no matter which way I'm going this side, am I going to get a point on the graph if I keep rolling this straw? Will this x value represent a point on the graph? Yes. So in terms of the domain, I'm going from where? Negative infinity all the way to positive infinity. And remember, infinity, negative infinity, you always use parentheses. On MATLAB, though, and you can't write this as an interval like we did. I'm sorry, you can't write this as an inequality like we did this one, because it's not bounded by a number. But on MATLAB, how are you going to write that answer? All real numbers. All real numbers. Okay, let's look at the next one. So let's find the range of this one first. Notice this time, notice the attributes of this graph. The arrows this time are pointing down. And so basically what's happening, if this is your straw, it's kind of like it's pushing the straw down, right? It's pushing the straw down towards what concept? negative infinity. So remember, when I go from bottom up, I'm going from negative infinity all the way, and then tell me where to stop. Right here. What? Remember, we're talking about the range, which is a set of y coordinates. What is that y coordinate? 5. And when writing the interval, you always go from smallest to largest. So what are you going to write first? Parentheses, negative infinity, comma, 5 with a bracket. So notice how this one looked compared to the previous one. Okay? All right, remember negative infinity, infinity, you're always going to put parentheses associated with it. As an inequality, what are you going to write this time? Y. Y is greater than, is that true? Less than. Because remember, this says that your largest y value is 5. All these numbers are less than that. So y is less than or equal to 5. Okay? All right, let's talk about domain. Domain. All right. So you see this arrow here keeps pushing this straw this way. So I'm going from, in terms of the domain, I'm going from where? Negative infinity all the way to positive infinity. And on a math lab, you would say what? Real numbers. Okay. All right. Now let's look at this one. On that worksheet that you picked up, that's due Tuesday. The direction says write the domain and range either in interval notation or in set notation. Remember that? Okay. So this right here, that's interval notation. That's interval notation. That's interval notation. That's interval notation. The set notation, remember, comes into play when we have something like this. Suppose I had this relation right here. First of all, is this relation a function or not a function? It's not a function. Because remember, when I draw that vertical line, it intersects it in an infinite number of places, right? Okay, so remember we talked about the fact that vertical lines are not functions. The vertical line fails a vertical line test. But we can still talk about domain and range. So let's do the range first. So the range, you go from the negative part of the y-axis to the upper part, the positive part of the y-axis. But notice that you have an arrow here, right? All right, so I'm going from where? Negative infinity all the way to positive infinity. Or you can say what? Are real numbers. Now the domain. Okay, notice that the arrows are pointing up and down. They're not pointing to the right, to the left, down, or up, right? Okay. So if I put my straw here, is this straw touching any part of this graph? No. So I keep moving until it touches it. So tell me when to stop. Right here, right? And that's it. I can't go anywhere else. So notice that the domain is only these x values right here. Notice, what are those x values? They're all 5s. Isn't it? So that's just one number. So since there's one number, you can't put that as an interval. You can just put it as a set. So you can say the domain is a set that consists of how many numbers? 1, and what is it? 5. And in fact, you knew it had to be 5 because remember the first worksheet where you were asked to graph x equal 5 or something like that? No y value. Remember, x equal a number is just a vertical line. Then that right here isn't all these x values 5s? So that's the equation, x equal 5. Notice x is what? 5. That's what you found. And remember, the domain is a set of x coordinates, right? The domain of x coordinates. Yeah, those are braces. You use set notation. Set notation. So those are braces. Okay? All right. So that was a quick review of what we did last time. All right, let's look at this one. Let's kind of review this one as well. So last time we talked about evaluating functions. Remember evaluating functions? So evaluating functions. So let's suppose we had this function. Now remember, how do you read this? Huh? F of, I was asking how do you read that? We know it represents the same thing as y, but I want you to say f of x, right? Okay, f of x is equal to negative 3x squared minus 5x plus 2. And let's suppose you want to find f of negative 2. Now remember what that means when you ask to find f of negative 2. So in this case, what does that negative 2 represent? The x value. And so if you want to find f of negative 2, basically you're asking yourself, when x is negative 2, what is the y value? That's what you're asked. Because remember, that's what f of x is, right? F of x is y. So basically, wherever you see the variable x, what are you going to plug in? Negative 2. You'll plug in negative 2. So f of negative 2 will be negative 3 times negative 2 squared. Make sure you use parentheses. Minus 5 times negative 2, and then plus 2. All right, and then we use the order of operations. Remember, please excuse my dear Aunt Sally. I do have parentheses, but there's not anything you can do inside the parentheses. It's just a number negative 2 in each case. So then we go to exponents. Do I have any exponents to deal with? Yes. So I do negative 2 squared first. Now, don't make a mistake, and some of you are going to do this because you're not very careful with your time. You're going to say negative 3 times negative 2 is 6, and then you're going to square that. That's not true. You got to square the negative 2 first, and then multiply. So that's 4. 4 times negative 3 is negative 12. A negative 5 times negative 2 is a positive 10, right? And then 2. So what's a negative 12 plus 10 plus 2? 0. So I found on the worksheet, you're going to say f of negative 2 equals blank. And what do you put in the blank? 0. Now, remember, let's kind of talk about what we said earlier. So basically, you're saying when x is negative 2, the y value is what? 0. So if you were to graph this function, and by the way, what kind of function is this? Is it linear, quadratic, absolute value? It's quadratic. So the shape's going to be a what? Parabola. Now, the one that you had to turn in last class period, those were easy problems. You had to find the vertex first. Remember that? Those were easy to deal with. Here, it's not. There's no way you can tell me what the vertex is. You're going to learn how to do that next semester. There's a vertex formula you're going to use next semester to graph this. You are going to graph those kinds next semester. All right. But as an ordered pair, basically what you found is this. As an ordered pair, because in one of the worksheets they do ask you, what is this as an ordered pair? As an ordered pair, f of negative 2 equals 0 is what? Negative 2, 0. That's what you just found. So basically, remember, you said when x is negative 2, the y value has to be 0. So that's your ordered pair. All right, let's look at this function. Suppose you had g of x equal negative x squared plus 5x. So g of x equal negative x squared plus 5x. And let's say you want to find a, which is g of 3. A, which is g of 3. So again, where we see the variable x, what do you plug in? 3. Now use parentheses. So be careful with this one, because if you go back to the function g of x, what is being squared? Is it negative x or is it x? Remember we talked about that at one point. No, it's x. Remember, if I wanted negative x to be squared, I have to put that in parentheses, but it's not in parentheses. So remember we talked about the fact a while back that there is a difference between negative 8 squared versus negative 8 in parentheses squared. You can easily say here that negative 8 is being squared. So what's negative 8 times negative 8? Positive 64. Here, though, you got to remember there's no parentheses. What's being squared? Just 8. And what's 8 times 8? 8 times 8 is what? 64. So this becomes a negative 64. So when you substitute the 3, you get negative in parentheses 3 squared plus 5 times 3. Now what's going to be that first term? Is it 9 or a negative 9? Negative 9, because what's being squared is 3. 3 times 3 is 9. That becomes a negative 9. And so what's negative 9 plus 15? 6. So G of 3 equals what? 6. All right. Now B, we're going to, the one on my math, you're going to see one like my math lab, one like B in my math lab. I didn't put one like this on a worksheet. So let's talk about how you're going to deal with this in my math lab. So in B, let's suppose you want to find G of 2/5. G of 2/5. So just like we did, wherever you see the variable x, you're going to plug in what? 2/5. That's what you're going to do. So I get negative in parentheses 2/5 squared plus 5 times 2/5. All right, and so remember 2/5 squared means 2/5 times 2/5. What's 2/5 times 2/5?
4.
Nope.
Oh, it's 4/25.
4/25. 5 times 5 is 25. So you get 4/25, right? So, but that is a negative 4 divided by 25. Plus, I'm going to leave this as, y'all agree that's 10/5? You could say 2, but let's just write it as 10/5 for right now. 5 times 2 is 10, and then you just have that 5 down here, right? So that's 10/5. Because remember, 5 times 2/5, 5 is the same thing as 5/1, right? Okay, 5 times 2 is 10, 1 times 5 is 5. All right, so if you need to, put 5 as 5/1. Now remember, in a previous course, you were asked to add these fractions that had unlike denominators. What did you have to do? Find a common denominator. What's your LCD? Let's use the least. What's the least common denominator?
25.
25. So then what you did was you wrote two fractions with 25 as the denominator. And then you wrote equivalent fractions, meaning this. Let's start with 10/5. 10/5 is equal to what fraction with 25 as the denominator? That's the question. So what you did was you asked yourself 5 times what is 25? What I do to the denominator, do to the numerator. So what's going to be this numerator right here? 50. And it kind of makes sense. 50 to 25 is the same thing as 2, right? Over here, the denominators are the same. So it means that the numerators have to be the same. So basically you're saying 25 times 1 is 25. Negative 4 times 1 is still what? Negative 4. And so what's your answer? What's negative 4 plus 50?
46.
46 divided by 25. Okay? Now you could use your calculator for the fraction part here. So let's remind ourselves how to use the calculator on this. So just make sure you know how to use your own calculator. So listen carefully to this. All right. So this particular calculator is easy to use. You just type in what you see. So I see a negative. The negative button is right here. So I type negative. Then I see parentheses. I put an open parentheses. Then I see 2 divided by 5, right? So I say 2 divided by 5. And then what else do I see after that? Close parentheses. And what else do I see after that? What am I doing to that? Squaring it. So there's your square. Well, there's your exponent button right here. So I'm just going to do this. There's a square button also right here, x squared. And then I'm going to say plus 5, what else do I see? Times, what else do I see? 2 divided by 5, right? And then I press equal, and I get 1.84, correct? All right, so I got 1.84. But remember, you want to leave your answer as a fraction. All right, so now what I got to do is I've got to convert this decimal back into a fraction. All right, well, your calculator can do that. See this button right here that says PRB? Well, right above that in blue, it's F to D, D to F. So the F means fraction, D means decimal. So go from fraction to decimal, decimal to fraction. But to get to it, you got to press that second function right here. All right, so here's what we're going to do. So I have this. I'm going to say second. So press second. And then press that P or B right here. And you see this. So now you can convert this to a fraction. Just press enter, equal, and you get this. What it did, though, was it wrote it as a mixed number. That's a mixed number. So it's 1 and what fraction? 21 divided by 25. That's what that says. So this is 1 and 21 divided by 25. That's what your calculator gave you. But you want to see if this right here is the same as this, right? So remember how to convert a mixed number back into a fraction? You say this times this first. So what's 25 times 1? And what's 25 plus 21? 46. So that's 46 divided by 25. Okay? All right, now. Okay, so when we graphed this function 3x minus 2, is this a linear function, quadratic, absolute value? Those are only three that we've talked about. It's linear. So it's a line, so we need 2 points to graph it, at least 2, right? So if x is, let's say, 0, if x is 0, what's 3 times 0? 0. And 0 minus 2 is a negative 2, so I'm going to plot the point 0, negative 2. If x is, let's say, 1, well, let's do 3. If x is 3, what's 3 times 3? And 9 minus 2 is 7, right? So 3, 7. And let's go ahead and graph this. So if I graph it, it's not going to come out very well because this is not a perfect edge. But all right, to get something that looks like this, right? Okay, so basically, remember function notation. So if I wanted to find, let's say f of 3. Let's just say f of 3. Remember a while ago we dealt with function notation? So I can, since the graph is given, I can even go to the graph and determine that, couldn't I? Because this means, based on our discussion earlier, this means that when x is 3, I want to find the y value. So here's my x value 3 right here. The point that corresponds to that is here, right? What is that y value? 7. So if I look at that point, that's 3, 7, correct? So f of 3 from the graph, I just locate x is 3 on the x-axis, and then I locate where that point is. So the point's here. So it's at what y value? 7. Right? I could have also, since the equation is given, I could have also just said 3 times 3 is 9. 9 minus 2 is 7. Okay? So same thing if I want to say f of 2. So if I want to say f of 2, let's suppose I didn't give you this equation, but the graph's there. So basically that says what's the y value when x is what? 2. So when x is 2, the point that corresponds to it is right here. Yes or no? Yes. Okay. What's that y value? 4. So this is the point 2, 4, isn't it? Let's check it now. What's 3 times 2? 6. 6 minus 4 minus 2 is 4. Okay? All right. Now that takes us to that handout I just gave you. So go ahead and take that out. To the handout I just gave you. Okay, so this is one you have, right? Okay, so let's do these. So you have enough information based on our discussions the last week and a while ago to answer this. So here's the graph. You're going to use this graph to answer these questions. All right, find f of negative 2. All you're given is a graph. You're not given an equation. You're not given a function. You're just given the graph. So remember what that means. That means what is the y value when x is negative 2. So what I've got to do is I've got to go to the graph and locate on the x-axis where negative 2 is. So do y'all see that negative? Oh, and by the way, since there's no numbers listed, assume that each grid represents 1 unit. So do y'all agree that this that I'm pointing to is negative 2 right here? Mm-hmm. Okay. So then I got to locate the point of the graph. So this is the point of the graph, right? Mm-hmm. All right. So I'm going to label the point. It helps if you label. So this point right here is x value negative 2. I just got to find the y value. What's that y value? 2. Okay. Remember, each unit represents 1 unit. So what is f of negative 2? What's the y value when x is negative 2? 2. So you put 2 in the blank. That's what you do. All right, let's look at B. Now, remember, B says this. Find the values of x for which f of x is 2. Remember, what does f of x mean? Y. So they're asking you this. This time, they're saying when y is 2, when y coordinate is 2, what are the x's? That's what they're asking. So remember a while ago we said for this one in part A, we located negative 2 on the x-axis because x was negative 2. Now we're going to locate on the y-axis. What are we going to locate? 2. So here's 2 on the y-axis right here, right? We locate the points corresponding to that. So there's this point. Y'all agree that point right here, the y-coordinate is 2, right? Okay. And we have this point, which we already know, right? Right here. Okay. Now, what's this x-coordinate right here? Let's see. 1, 2, 3, 4. Y'all agree it's 4? All right. Okay, do some of those x's are. What are those x's? What are the x-coordinates? This one is what? Negative 2, and this one is what? 4. So negative 2 and 4. That's what you do. So when y is 2, my x-coordinates are negative 2 and 4. Part C should be easy for you because you had a worksheet on that previously. Remember, the x-intercept is where the graph does what? Crosses the x-axis. If you look at the graph, how many places does it cross the x-axis? 2. What are they? Negative what?
Negative 1.
Negative 1 and
On 4.
not 4. Positive 3, right? So negative 1 and 3. Negative 1 and 3. Part D is similar to part A. So find f of 0. So again, when x is 0, what is the y value? So x is 0. Remember, you look on the x-axis. So x is 0 at the origin, right? Right here. So we got to locate the point that corresponds to it. Well, that's this point here, right? Makes sense because what is the x-coordinate for this point right here? The x-coordinate? 0. And that's what I'm asking. But what's the y-coordinate? Negative 2. So what's f of 0? Negative 2. which also happens to be the y-intercept, right? Because remember the y-intercept, to find, remember in a previous worksheet, to find the y-intercept, you let x be what? 0. So just remember that f of 0 means that you're finding the y-intercept. But you don't have to know that. You just do like we just did. But just keep in mind that that is the y-intercept. What is a y-intercept? The next one. What is y-intercept? Where across the y-axis? Where does it cross the y-axis? Where? Negative 2. So D and E mean the same thing. F of 0 means the same thing as what is the y-intercept? Remember, the y-intercept is where the graph crosses the... I'm sorry. The y-intercept is where the graph crosses the y-axis, but it's also where x is what? 0. And then part F, you just want to complete that statement, that fill in that blank. So the 6 represents which coordinate? X. So I go along my x-axis and I find 6. So do y'all agree that 6 is right here that I'm pointing to?
Yep.
I locate the point corresponding to it that's up here. So when x is 6, what's that y value? 6. So what's the answer? 6. All right, so question number 1. All right, let's do number 2. This time the graph looks like this. Kind of the same information. So you want to find f of negative 3. So remember, that means when x is negative 3, what are you finding? The y value. So locate negative 3 on the x-axis, negative 3. That's right here. What is that y value that corresponds to it? Negative 4. Because if you locate the point, there's the point. The coordinates of that point is negative 3 comma negative 4, right? So when x is negative 3, what's my y value? Negative 4. So you put negative 4 in the blank. What do you think f of 4 equals? 2. Y'all agree it's 2? Because when I locate, remember, if x is 4, what's the y? So x is 4 here. Here's the point corresponding to it. Those coordinates are 4 comma 2. So when x is 4, what's my y value? 2. C is like the previous problem. Find the values of x for which, remember, f of x means the same thing as what? Y. So find the values of x for which y is negative 2. So y is negative 2. So I'll go along the y-axis and I locate negative 2. So negative 2 is right here, right? So how many x's are there? No, how many x's are there? 2. Because there are 2 points corresponding to that y coordinate of negative 2. There's this one, and there's this one. Y'all agree?
Yeah.
All right. It helps if you label the point. So let's do the one that's on the right. What are the coordinates of that point? 7 comma negative 2. Good. What are the coordinates of the point on the left? Negative 2, negative 2. So what are those x coordinates then? Negative 2 and 7. Okay, negative 2 and 7. The next one, what are the x-intercepts? Well, remember the x-intercepts is where the graph crosses the x-axis. So where does the graph cross the x-axis? Negative 1 and 6. What is a y-intercept? That's where the graph crosses the y-axis. So where does the graph cross the y-axis? At positive 2. All right. Then you want to find f of negative 50. Now notice that if you look at this plane right here, you don't see a negative 50 for x, right? It kind of, the furthest you have on the left is negative 10. You have negative 9, this is negative 10 right here. But you can still find what f of negative 50 is, because remember that means when x is negative 50, what is the y value? What do you think it is? What do you think f of negative 50 is?
Negative 4.
Anybody else? You think it's different than negative 4? Or you just don't know? Who doesn't know? All right. Well, look at what this is. What is this? What does it say right here? This is what kind of ray? Horizontal. So that means that all these on this keeps going, right? So all of these y values are what? -4. Just keeps going. You see this arrow? So that means that if this is negative, if this right here is -50, then that means my y value is what? -4. Let's skip G for right now and go to H. So the question in H is this: is f of 8 equal to 2? Yes or no? F of 8. Yes or no? Huh?
Yeah.
So you're saying f of 8's 2?
No.
No, because look, if this is x right here, then I'm sorry, if this is 8 right here, then that's that point corresponding to it. Yeah, so the answer is no. In fact, the answer is no. In fact, f of 8 actually equals what? -4. -4, right? Does f of 6 equal 0?
Yes.
Yes. In fact, that's the X-intercept. So when x is 6, my y value is what? 0. All right, now let's go to part G. So the question in part G is this: now they're just asking how many values of x does f of x equal to? Remember, f of x is the same thing as y. So y is 2. Now we talked about this idea in a previous lesson. So y is 2. So where's y2 on this graph? So here's 2 right here, right? What points correspond to that? In other words, what point will have the y coordinate 2? All these, right? How many are there?
Infinity.
An infinite number. Because you're just thinking whole numbers. We talked about that, but isn't 1.25 when x is 1.25 in the y value 2? When x is 3.000008 in the y value 2? So how many values of x is y equal to 2? An infinite number. So an infinite number. So infinite number.
It can be negative and positive, right?
No, actually it starts at 0. From 0 to 5 is when you see when x is 0 and when x is 5, that's where my y value is 2. So x is not negative. When x is negative, you get these y values right here.
Okay, in between that specific,
Between here and here is where x is 2. I'm sorry, y is 2, excuse me. Where y is 2. But there's still an infinite number of x values there. Remember we talked about it, it's very hard for students to understand that. It's bounded, but there's still an infinite number of points in there. It's very easy to see that if there's an arrow, it's infinite. There's an arrow involved, but there's no arrow involved, but there's still an infinite number of values in here.
yeah, because we can break down a number to an infinite number.
Yeah, into multiple decimals. So you can have 2 point and then an infinite number of digits behind it. 3 point, 4 point, and so on. Okay? All right, that takes care of this. So I'm going to give you a worksheet that goes with this.